So hello and welcome to a new video. Today I will be doing the Microsoft Excel World Championship 2024 qualification round of 64 PM, so America's case portal by Grayson. I will not spell the last name. So this was kind of good case I found, a little bit different than normal. A lot of indirect, what a lot of people don't like. But I don't have a strong opinion on that. So here, let's do this case. As always, I will skip the instructions, and it could be I found in my only and attempt. I did this case once before. In my only attempt, I found here you could build, for example, one pre-programmed lambda, but here, never mind. I brought in my normal lambda collection. This will be good enough. So I will skip the instructions and go to level 1. How many portals are there in the area you're in? So we have the different area tabs with the same size of portals or non-portals, and we will need to count them. So you need here an indirect function, indirect area, and the area name, then an exclamation mark, and here I have the area code. And I get this here then split array 256 because it's 16 squared. And here we can now use here sum minus minus if this equals a portal, so this small o. We could also do here and count if, for example, count if, but here I will stick to the sum minus minus because later it will be more useful, as I found in my first attempt. So level 1 solved. Level 2 is also super easy. Just bring here a map function, lambda a, swap this out here, semicolon, and wrap this in a sum function again, and we can track this now down. So this will bring in all the areas, then we have an array and we sum this up in a sum function. So now it gets more trickier. Bring this down here. Here we have our areas. So now we have an error because if the row number is even or uneven, we filter back on this. And therefore I will use here the choose function. Choose, with an H. Choose sequence. We have 16 rows, so half of it will be 8. If here starting in the start number, if this is even, and then we start with 2, otherwise with 1. Step will be 2, close the brackets, close all those brackets. And we have an error. Great. And probably bring this here to a different section. Yeah, now we're talking. So 3 levels solved so far. Yeah, 4 minutes in. That's okay. Which area has a portal in this address? So here we have an address. We want to know the area, and therefore I will use here a map function. I know that there are 64 areas. Sequence 64, lambda a, indirect area, and a and an exclamation mark and the position. Close all of this, and we now get a spilled array, and we need to now find out where there is an O, and we will do this with the xmatch function. So I match for a small o. In here, I get the number, and I will concat this with the word area. Bring this in the cell here, drag this down, and we are finished. Based on your starting position and area, what is the number of steps to get to the closest portal? This is getting more tricky, so here medium, but I have some lambdas for this, as always. So first, let's build a let function. So I gives me the whole portal thing. Area, and this here, and explanation mark A1 to J18 or something. Need to check this. P16. P16. Yeah. Now we're talking. So, and we want to have the closest portal to this position, and the positions are counted with diagonals are counting as 2 steps. Also always important. So I want to have the addresses, the address of range area for I, and so the addresses. And now I want to have a distance map, distance between cell references. First cell reference is given here, then I want to have my cell references I created, and here 1 because diagonals are counting as 2. Name this d4 distance. Yeah. This will spill, yeah, because it cannot handle this kind of thing, so I need to bring this into a single column, I think. Yeah, I need to check this elsewhere. Are we getting 256? Yeah, this looks great. And now we need to filter. We need to filter to call. We need to filter to call of I. To call of no fast. We need to filter d, so the distance if to call of I equals our portal sign. There we get our distances, and now we wrap this in a min function and bring it in here. Yeah, track this down. We're good to go. Given an area and position, what address is the closest portal? So it's basically this, but with a few other things. So more than one portal, you should prioritize that with the closest row. But as I didn't follow this rule for in my first try, it's only important for the first 2 levels. So get rid of those kind of unnecessary stuff. Either do it fully or uncommitted, or let this out. So so instead of min, I bring in here all the positions, and instead of distance, I bring in the area. So like the positions, and then I want to sort this filtered stuff. So my addresses, sort by these addresses based on my distance ascending, yes, and the column of indirect of those addresses. Yeah, I could do this. Not beautiful, but it will be okay. So here, there we are. First filter A to call I equals O contra X. So name this F, and then sort by F if filter A, oh not, so this is F, sort by F is, the filter D, to call I equals O. Sort order is given, let's take a look. So order is fixed, so let's take a look. Sort by filtered is given. So B1, B5 will not be the answer. Yeah. B5, 3, 4, 0, 12. Okay, nothing will be the answer. Oh yeah, I'm dumb. So P12, wrong. L16, right. P16, also wrong because L16 is the answer because it's the furthest upper left. So I then need here to add column indirect of F. Here should be okay. Sort order is given. Now we have L in front. Use the add sign or intersectional operator or something like this. Yeah, now we are good to go. Level 6 solved. Now it's getting tricky to understand because here you need these other next areas, but in this area do not go any further, so only these areas are out of interest. And I will therefore use this lambda from here. Put this in here and we will use a scan function. Scan function. Initial value is the position. These are my arrays, but I will not use the last one because I don't need this. Lambda position and NA for next areas, but don't put here in open brackets, otherwise we will get an error. This is NA, and now we need to investigate. So the difference is calculated with P, because then we are scanning from like the position before. Close all the brackets. We get here an answer. Let's check this for the given example. Reference error? Yes, of course. G4 is given, H4 is given, then there isn't anything given, but we'll be fine. So wrap this in another let function. Let S for scan, and then distance stuff. I don't have something for moving along this path. This will be added to my lambda collection, I have this on my list. But I will use a map approach on this. So map haystack this and drop from S the first column and S not Lebsach. Lambda A B distance between cell references A and B. This is 1. Close all this stuff. 500 isn't good. Yeah. Drop -1. Yeah. 14. Yeah, I've dropped in the first row out, and then we had like the same here, and then we need to sum this and bring it in here. The scan function is super useful here, but yeah, you need to know how to use this, and a little bit confusing with like the last area isn't of interest. So we've done all the levels in like 15 minutes. Yeah, that's okay. Which area has the most portals? How many portals? We use this formula from here. Then map sequence 64 lambda a. Use the function here. So switch this against a. We get like a split array, and then I use max match. Max match to get here the number with area and combination. Drag this in here, and we're good. Which area appeared most across all levels using the all levels excluding samples? Bring in the bonus setup here. I could also use my macro, but since I got this function, I only use this function. So I think this will be enough. Yeah, here these data, I need to use this most of value in area. No delimiter. I get here a list, so odd of course, but then it's 11 with a count of 10. So area 11, which is right. Across all level 7 games, how many areas have you been in that count the number 6? So level 7. How many 6 numbers are in there? So is there? No, there isn't like 66. So we can concatenate this. Not this, but this here. And then do len minus len not sum substitute in this text here is 6 against nothing, and we're at 13. I will only use single cell here. Want to get like competitive and do it the bow way. Take the sum of the row number for all portals in each area. Which area has the highest total figure? Sum of row numbers for each portal in each area. Okay, which one can I use? Yes. So I don't need this stuff here. So map sequence 64 lambda a. Here this is a. This is, but it should be fine. Yeah, better safe than sorry. To call of this filter of this. I don't need a distance here. I only want to have a filter a if to call of I equals O. Then I want to get the row indirect because I'm getting there the addresses. And then I want to have this sum here. And I'm getting there the numbers. And I now need to have the highest total figure. So in the next match, again, it's 40. Concatenate with area and put it in here. And we're fine. Last question. Which area doesn't have any portal in column A to K? So I'm using this here, adjusting this for K, map sequence 64, and now I get a split array X match for the 0 in here with the area concatenation. Area 63, not area 64. Or is this in Nevada? Is it 64? I don't know. So 1,250 points in like a little bit over 20 minutes. As I said, I did this case once before and I found it was a super interesting case. And also if you have like a few lambdas you can use here, know how to use indirect, a little bit of let structuring for the later levels, then this case is like a speed case. I don't know, I think Denver was super fast as always. So thank you for your attention. I hope to see you also with the other cases. I'm currently working on like Klinsmann case and then I will go further to round of 32 and round of 16. So yeah, stay humble and stay on this channel and also subscribe. Thank you. Bye.